Hi everyone, welcome back. Let's write some more Leetcode today. Today we are solving threesome. I will go over 2 ways to solve this problem, but we'll only go over the coding for the optimal solution. If you are only interested in the optimal solution, then feel free to skip to the timestamp. So the problem states that we are given an integer array called nums, and we want to return all the triplets of nums I, nums j, and nums k, such that I does not equal to j, I does not equal to k, and j does not equal to k, and nums I plus nums j plus nums k equal to 0. So basically we want to find all the triplets where if we add them up they will equal to 0. And the indexes of each number has to be unique. And also the solution set must not contain any duplicate triplets. So if any of these triplets can be made more than once with the combination that we are given, then it should only be returned once. So if we look at these 3 examples, in example 1, -1 plus -1 plus 2 is equal to 0, and -1 plus 0 plus 1 is equal to 0. So that would be our output. And for example 2, none of the triplets add up to 0, so we just return an empty list. And in the last example, 0 plus 0 plus 0 is equal to 0, so we return a triplet of 0 and 0 and 0. So, how can we solve this problem? One way that we can solve this problem is that we can use 3 for loops that are nested, and we will iterate through all the for loops. And each time we iterate, we want to add up the 3 indexes, and if they equal to 0, then we add to the resulting list that we have. So let's just go through this example. So we start at -1, 0, and 1. They equal to 0, so we can add them and iterate to the next element. Add these 3 numbers, they don't equal to 0, so move on to the next. Add these 3, they don't equal to 0, so move on again. We add these 3 numbers, they still don't equal to 0, so now we iterate to the blue and we restart the green index over here. Add these 3, they don't equal 0, so move on. Add these ones, they still don't equal to 0, so we move on. Add these together, they don't equal to 0, so now we move blue over here and then we iterate green over here. Now we add these 3, they do equal to 0, so we can add to the resulting list. So I think by now you can see how this algorithm works, and if we go through the entire problem, the time would take O of n cubed time because we have 3 for loops that are nested. So there's actually a more efficient way to solve this problem, and we can go over that approach right now. So a slightly more efficient way to solve this problem would be to use a 2-pointer approach where we have a left pointer and a right pointer. So we will add the 3 numbers, and if the number is less than 0, then we will shift the left pointer to the right because we know the number shifted to will be a larger than or equal to number. And if the 3 numbers we add are greater than 0, then we will shift the right pointer to the left because we know shifting the number to the left would be a smaller number, so it would bring the number closer to 0 if it's originally greater than 0. And if the sum is equal to 0, then we will shift the left pointer and the right pointer. And we continue that algorithm until these 2 pointers meet, and then we can shift the red pointer. And then we will keep shifting the red pointer until it gets to the end. So let's just go over this example. So we start here, we add these 3 numbers, it's less than 0, so we shift the left pointer. We add them together, it's still less than 0, so we shift again. Add them together, still less than 0, so we shift the left pointer again. Add them together, it's still less than 0. And once we shift again, these 2 pointers will meet, so now we shift the red pointer, and we set the left pointer back to where it belongs. So now we add these 3 numbers, they do equal to 0, so we add them to the resulting list. And since they equal, we shift the right pointer and the left pointer, and these 3 numbers also equal 0, so we also add this combination to the resulting list. And now so we shift the left and right pointer again, and then they meet, so now we shift the red pointer, and then we set the right and left pointer to where they should belong. We can skip this number because it was the same as the previous number, so it would be repetitive work. So now we add these 2 numbers and they are greater than 0, so we shift the right pointer, and now that they meet, and we can shift the red pointer again and place the left and right pointers at where they belong. Now since 1 is greater than 0 and it's at the red pointer, then we can just end the algorithm and return the result because everything to the red would be greater than or equal to 0 if red pointer is already greater than 0. And if everything is greater than 0, then the sum will for sure not be 0. So the time complexity of this problem will be O of n squared because we have a for loop for the red pointer and then a while loop for the left and right pointer. And the while loop will iterate until these 2 pointers meet. So it will be O of n squared. And the space complexity of this problem would be O of 1 or O of n, where n is the length of the list and it's depending on which sorting algorithm that you use. So it could be O of 1 or O of n. So now let's get to the coding part. So first we'll write out the resulting list. We'll call it res, which stands for result, and we're going to sort nums. So nums.sort, and now we're going to loop through the list for that red pointer earlier. So that's the for loop for the red pointer earlier. And if the value is greater than 0 at the red pointer, then we can just end the algorithm and so break. And if the value is equal to the previous value, then we can skip it, because otherwise it will be repetitive work. So we could skip it. So value equals nums of index -1. And then we can just continue. So now we will set up the left and right pointer. The left pointer will always be 1 greater than index, so index +1. And the right pointer will be the length of nums -1, so it's always at the end. Now we'll set up the while loop for the left and right pointer. So while left is less than or equal to right. So first we will find the total value. So value plus nums of left plus nums of right. And the total value we'll just set to total, call it total. If it's greater than 0, then we shift the right pointer by 1. And if the total is less than 0, then we shift the left pointer by 1. And if it is equal to 0, then we just add it to the resulting list. So we append it to the resulting list. Plus nums of right. And after that, we shift the left and right pointers. We shift both. And after shifting, if the value on the left is the same as the previous value before shifting, then we will shift left again to avoid repetitive work. So if nums of left is equal to nums of left -1, and we want to make sure that left is still less than right. So we gotta make sure left is still less than right. Sorry, I made a typo. And then, so yeah, we shift the left pointer still. We continue to do that until the two left pointers are not equal. And after that, we can just return result. Okay, let's see if it works. Okay, perfect. Hope this was helpful. Thank you all for watching. If you have any comments or questions, please feel free to leave it down in the comment section below. And I hope to see you all again soon.